Welcome to the equation of a plane using the normal vector. The standard form of an equation of a plane containing the point x sub 1, y sub 1, z sub 1, and having the normal vector with components a, b, and c is given by a times the quantity x minus x1 plus b times the quantity y minus y1 plus c times the quantity z minus z1 equals 0. So the point on the plane give us the constants of the binomial factors, and the components of the normal vector ABC give us the constant factors A, B, and C. Now once we have this equation in standard form, we can distribute combine like terms to come up with what's called the general form of a plane. Let's take a look at the idea behind where this equation comes from. Here's the graph of a plane and the normal vector in black. Now if we pick any 2 points in the plane to form another vector, it would still have to be perpendicular or orthogonal to the normal vector. So if we were to find the dot product of the normal vector and any vector in this plane, it would have to equal 0 because they would be orthogonal. And this is the idea where the equation of the plane comes from. So again, if we take the component form of the normal vector, which is perpendicular to the plane, and dot it with another vector formed by any 2 points in the plane, the second vector would have component form as we see here. And since this vector is in the plane and this vector is orthogonal to the plane, the dot product must equal 0, and this dot product gives us the equation of that plane. Let's go and take a look at an example. Here we want the standard and general form of an equation of a plane that contains the point 3, negative 2, 5, and has the normal vector 5, 2, negative 3. So the equation will be 5 times x minus 3 plus 2 times y minus negative 2 or y plus 2. And the z component of the normal vector is negative 3, so we'll write down minus 3 times z minus 5. And this must equal 0. And this is the standard form of the plane. Again, to emphasize where this equation came from, the components of the normal vector gave us the 5, the 2, and the negative 3. And then the point 3, negative 2, 5 gave us the constants of the binomial factors. Now to find the general equation, we just need to distribute and collect like terms. So we'd have 5x minus 15 plus 2y plus 4 minus 3z plus 15 equals 0. So we're going to have 5x plus 2y minus 3z, and a constant term is going to be negative 15 plus 4 plus 15. That's going to give us positive 4 equals 0. Let's go and take a look at the graph of this plane. In the next video, we'll take a look at how we can go about graphing these on our own paper. But for right now, if we rotate the coordinate system, you get a nice idea of where this plane is in space. Let's go and take a look at another example. We want to determine the standard and general equation of a plane containing these 3 points. Well, this problem is going to take a little bit more work. We do have to determine the normal vector to this plane. One way to do that is to determine 2 vectors in the plane containing these 2 points in component form. We'll find their cross product, which will give us the normal vector. So let's first find the component form of 2 vectors using these 3 points. We'll call this point P, this point Q, and this point R. Let's find the component form of vector PQ. That'll be negative 3 minus 1, 4 minus negative 1 or 4 plus 1, and negative 1 minus 2. So the component form will be -4, 5, -3. Now let's find the component form of vector PR. We'll have 3 minus 1, -2 minus -1, or -2 plus 1, and 5 minus 2. So the component form of the second vector will be 2, -1, and 3. So again, these are two vectors in the plane. So if we cross these two vectors, we will get the normal vector, which will help us find the equation of that plane. So let's just go ahead and call this vector V, call this vector W, and we're going to cross the two vectors. Remember, that's going to be equal to the determinant, where the first row will be I, J, K. The second row will be -4, 5, -3. And the third row will be 2, -1, 3. Let's go ahead and evaluate this using the cofactor expansion method. So this is going to be equal to the 2 by 2 determinant formed by eliminating row 1 and column 1. So we'll have 5, -3, -1, 3 times vector I minus the 2 by 2 determinant formed by eliminating row 1 and column 2. So we'll have -4, -3, 2, 3 times vector J plus the 2 by 2 determinant formed by eliminating row 1 and column 3. So I have -4, 5, 2, -1 times vector K. So we're going to have 15 minus +3, that'll be 12i, minus, it's going to be -12 minus -6, or -12 plus 6, that'll be -6, minus -6 will be +6j, plus, here we're going to have 4 minus 10, that's going to be -6, so we'll change this to -6k. So the component form of the normal vector is going to be 12, 6, and -6. Now any normal vector will work, so I could take a scalar multiple of this normal vector instead of using this one. And I think I'll do that because all of these components have a common factor of 6. So we'll use 1/6 times this vector as our normal vector. So we're going to have 2, 1, -1 for our normal vector. Let's go ahead and take that over to the next screen. Now we have to decide which point we want to use to create the equation of the plane. Let's go back to the previous slide. And let's go ahead and just use this first point P, 1, -1, 2. And this is all we need to find the standard equation of this plane. We're going to have 2 times x minus 1 plus 1 times y minus -1, or y plus 1, minus 1 times z minus 2, and this must equal 0. Now we could go ahead and eliminate these 1's here if we wanted to, but we'll go ahead and call this the standard equation of the plane. And now to find the general equation, we'll go ahead and just distribute and combine our like terms. So we'll have 2x minus 2 plus y plus 1 minus z plus 2 equals 0. So we'll have 2x plus y minus z, and our constant term is going to be -2 plus 1 plus 2, that'll be plus 1. And this equals 0. That'll do it for this video. Thank you for watching.